This video tutorial will show how to perform a manual alignment. So I'm starting off on Blackboard and I'm going to download a file. So I did a regular left click there. I'll come into File Explorer, and the default location for where that download ends up is in the Downloads folder. Now you'll notice that this gave me a zipped file. So this folder has a zipper icon on it. We have to right click and say Extract All and Extract to get that to come in. Now I'll X out of the extracted folder, and the reason is I'm going to come back and delete the zip folder so that way I don't accidentally try to open up a file that is inside of the zip folder. I'll go back over to Calypso here, and I will go File, Open, and I'm going to come into the Downloads folder, into that folder I just extracted, and you may have to browse a couple folders deep. You're looking for the inspection file type, and then press Open. Now at this point the CMM has already been turned on, and you can see if you look in the in-person view here that we already have the 3x50mm probe on the CMM. So if we look on the computer screen, we see the CMM tab is all green for CMM settings and stylus system. If we move to the measurement tab, base, start alignment, and clearance plane are both green. Temperature compensation will always be yellow because we don't have any temperature comp probes on our machine. Characteristics is empty, and then if we look at the features tab, there are only 3 features in it. So all we're going to do today is to execute these 3 features to create a coordinate system on the part. Now notice where the coordinate system is on this particular part. It is at the intersection of the top surface, the front plane, and the right plane. So our first move is we have to fixture the part. So looking in the bottom right to the in-person view, I will grab the part here. This has a socket head cap screw in it. The Allen wrench is over next to the rail of the machine, and I'm going to count 1, 2, 3 threaded holes over, and 1, 2 threaded holes up. And I'm going to orient the part so that the angled plane is on the left side, and there's also an angled plane on the back side here. All right. I'm lightly going to tighten this down, just finger tight. Really, you don't have to go very tight for anything in inspection. You're not socking this down like it's a CNC fixture. So looking back at the computer screen, I will click on plane 1 in the Features tab. I'll hold Shift and click on point 1 in the Features tab, and I'll come down here and click on Run. Now there's a lot to this dialog. The main things that we're checking for here is make sure your dialog matches the screen, but manual alignment, clear existing results, and speed is set to 55. Right? So we will, on the controller, we will slow our speed knob all the way down. We're going to always slow that all the way down at the beginning and end of each procedure to make sure that the machine does not move on us unexpectedly. We'll hit Start, and we notice on the computer screen that the manual alignment dialog box comes up. It wants us to touch plane 1. Looking on the computer screen, we see the arrow right here that shows we need to touch a point on this location of the part, and as soon as we touch that, then that yellow arrow will move to the next point that we need to touch. Where it says number of probing points, the nominal is 3 and the actual is 0. So we need to touch 3 points total. We have not touched any yet. So to move this machine around, we will press the little lock icon here, otherwise the joysticks are not active. And notice when I move this joystick around, we're actually seeing no motion at all on the machine, and that is because I have the speed dial slowed all the way down. At this point, I'll turn the speed dial all the way up, and that allows me to go maximum speed on the machine. I'll drive over to the part. The right joystick controls the X and Y axes. That's X, that's Y. And the left joystick controls the Z axis. You press down, it goes down. You go up, it goes up. So there was 1 point. Notice that it was recorded on the screen. So now my nominal is 3 and my actual is 1, meaning I've probed 1 point. I'll probe another point close to where it shows on the computer screen, and then I'll probe the 3rd point down here. So to see where those points were, it was point number 1, 2, and 3. So now the manual alignment dialog has changed, and it's now looking for 2D line 1. It wants 2 points. We've touched 0 points so far. Now pay attention to the graphic. Just out of force of habit, I happened to go over here, and I was about to touch off to the front edge, but based on where the coordinate system is here, I really want to touch the right edge. So I will drive over to the right edge of the part, drive into the part. That recorded 1 point, and the second point is at the back of the part, so I'll take that one as well. Now the manual alignment dialog changes again. Now our nominal point is 1. We need to take 1 point. So far we have taken 0 points. It looks like this point wants to be on the front of the part, right here. All right. After that, we want to lift up, about a ½ inch or so above the top surface of the part, and on the computer screen we have a warning that says caution, CMM being changed to CNC mode. Say OK, and we again want to slow our speed dial all the way down and then slowly open it once we see where the machine is going. And you want to keep your hand on the speed dial the entire time, because if you see something doesn't look right, you can slow the speed dial all the way down and notice that the probe has stopped moving completely, and as I open that speed dial back up, now it is moving around. Alright, so don't be afraid to fully close down that speed dial if it looks like something isn't going right. Now after all that, typically we would get a dimension report. However, in the characteristics list over here, we don't have any characteristics. So all this lab is designed to do is show you how to move the machine around and how to pick up a coordinate system. Well, let's go verify that our coordinate system is correct. Well, we'll move over to where the origin is. So you'll have to unlock the joystick at this point and move to the approximate origin. So you can see in the real world I've moved the probe over the corner of the part so that it is just above where this little XYZ icon is on the computer screen. Right? So I've moved the probe to replicate our origin, and now I'm looking in the stoplight window. So on the computer screen in the upper right, we have our red, yellow, and green light window, and if we move about toward the bottom of that, you can see we have a little pull down where we can select from CMM system or base alignment. In CMM system, our X coordinate is currently 11 inch 288, our Y is minus 15 inch 021, and our Z is minus 14 inch 610 or so. Alright, well if we hit the pull down there and we switch that to base alignment, notice that this is now reading out based on parts coordinate systems as opposed to machines coordinate system. So if you hit the pull down and go to CMM system, that is reading out based on where the CMM is when you home it. And if you hit the pull down and switch it to base alignment, that's reading out based on the parts coordinate system. So here I can see the location of my coordinate system is correct, but now I want to drive positive down the x-axis, and I just want to verify that this x-axis number here did move in the positive direction, and it's not a case where the y-axis moved instead of the x. If you touch the points in the wrong order, you can flip a coordinate system backwards, you can flip it 90 degrees, or any combination. So if we move the x-axis in the real world, and we saw that the y-axis was changing here, that would mean that we had touched the points in the wrong order, and our coordinate system is rotated 90 degrees. All right, but it looks like the x-axis is correct. Now we'll go back to the origin, and then we'll drive up the y-axis. And I'm just verifying that this y-axis coordinate right here is actually correct. Here I can see it move to about 1.5 inches, and that it does reflect what I see in the real world. So this coordinate system has been set up correctly. Right. Now, the second part of this exercise, just to drive home the point of how a manual alignment works, is what happens if we loosen up this part, and we now move this part just one screw hole to the right. Now, you do have to be careful moving this too far. If you move this part too far, you'll move it out of the machine's measuring volume. So I moved it 1, 2, 3, 4 threaded holes to the right and 1 up. So I'm now in this location here, and I'm going to come back to the Features tab in Calypso. I'll highlight Plane 1, hold Shift and highlight point 1, and I'll hit Run. And all the settings should be set here. Again, just confirm manual alignment, clear existing results, and speed is 55. We'll slow our speed dial all the way down on the controller, and we'll again come over and take our same points. So here we're driving in for point number 1, point number 2, and point number 3. We notice the manual alignment dialog updates. It now wants a line on the right side, so we have 1, 2, and then it wants 1 point on the front, so we'll come over and take 1 point on the front. Okay, so I will say OK, and the machine will come back and re-execute that exact same program. And what it's doing right here is called an automatic alignment. The automatic alignment is refinding the part, whereas the manual alignment is the operator drives over and touches specific features on the part. So after the manual alignment, the program will automatically do the automatic alignment just to find a more precise location of where the part is. Okay, after all that, I will again come over to the base alignment dropdown just to show you how this works. I'll switch it to CMM system. I will manually move the probe in the real world until it's just about at the origin. And notice now that my x coordinate is at 15 inches, my y is at minus 15, and my z is at minus 14. Whereas before, when we were in the other threaded hole, that x position was at 11 or so. Right? So the CMM system says that we are in a different location, which we know because we moved the part in the real world. But now if we look at our base alignment, we have updated our part's coordinate system so that it is in the new location. If we left our part's coordinate system alone, and it was still set to this threaded hole over here, and we moved to this location in space, we would see that we were about 5 inches or so off. But because we reperformed the manual alignment, we have updated the location. The long and short of this entire exercise is if you move the part, you have to tell the machine that you moved the part. How do you tell the machine that you moved the part? You perform a manual alignment, and as soon as that's done, the machine goes back and reperforms the automatic alignment to find a more precise location of where the part is. Thank you for watching this tutorial. See you at the next one.